Welcome to CertExam's YouTube channel. In this video, we will discuss the topic IPv6 addressing. Internet Protocol version 6, that is IPv6, is the next generation protocol for Internet networking, defined by IEFT, short for Internet Engineering Task Force, which is often treated as successor to Internet Protocol version 4, which is IPv4. IPv6 potentially offers enhancements, which include increased addressing capacity and capabilities, QoS control, mobility, built-in IPsec security, and improved routing efficiency. IPv6 address is 128 bits in the length represented in hexadecimal, whereas IPv4 uses only 32 bits. IPv6 address consists of 8 groups of 4 hexadecimal digits separated by colons, and which mainly consists of 3 segments called global prefix, which is of 48 bits, subnet part with 16 bits, and interface ID, called as the host part, with 64 bits. Example of an IPv6 address: 2001:0DB8:85A3:08D3:1319:8A2E 0370:7334. The first 3 octets constitute global prefix, the 4th octet constitutes subnet part, and the last 4 form the interface ID. Also, one set of zeros in the address can be replaced by double colon, but only once this can be done as per rule. IPv6 loopback address. Loopback address is a special IP number that is designated for the software loopback interface of a machine. The loopback interface has no hardware associated with it, and it is not physically connected to a network. IPv6 loopback address is as given, also expressed as ::1. IPv6 Reserved Address Space. IPv6 reserves 2 special addresses. They are as given. IPv6 header contains the following things. Version: this field contains the version of the IP used in the packet. It is of 4-bit in IP version 6. Traffic class: this is an 4 bits field determining the packet priority. Priority values subdivide into ranges: traffic, where the source provides congestion control and non-congestion control traffic. Flow label: this 24 bits specify the QoS management. Originally created for giving real-time applications special service, but currently unused. Payload length: this 16 bits determines the payload length in bytes. When cleared to 0, the option is a jumbo payload, hop by hop. Next header: this 8 bits field specifies the next encapsulated protocol. The values are compatible with those specified for the IPv4 protocol field. Hop limit: this is an 8 bits field newly introduced in IPv6. It replaces the time to live field of IPv4. Source address: this 128-bit field determines the logical address of the host that is sending the packet. Destination address: this 128-bit field determines the logical address of the host that is receiving the packet. Thank you for watching. Do check out other videos on our channel.